Good morning, my dear students. We said before in the lesson 1 electric lamps, we talked about the types of the electric lamp, the function of each port. Today we will complete the lesson. In this lesson, we will talk about the electric circuit, the methods of connection, and some live applications. Let's start. First, we will talk about the electric circuit. What is the meaning of electric circuit? It's a closed and continuous path. Again, it's a closed and continuous path in which or where the electric current passes through. Again, it's a closed and continuous path in which the electric current passes through. What is the meaning of a closed? Closed means all its parts must connect together. Each part must connect with the other parts. Okay, the electric circuit consists of 3 main parts. How many parts we have? 3 main parts. The first part is a battery. The second part, electric lamp or light bulb, whatever. The third part, wire. Again, we have 3 parts: battery, light bulb, and wire. Battery. We can use battery in the electric circuit as a source of electricity. What is the meaning of source of electricity? It gives us the electric current. We know that the electric current comes from the battery, from the positive pole to the negative pole, and passes through the wire. So the first part in the electric circuit is a battery. Battery is a source of electricity. Okay, the second part is light bulb. Is what? Light bulb. What is the function of the light bulb here? It will emit light. It will give us light when? At any time? No, when the electric current passes through it. Again, do you remember when we said the function of the filament that will emit light when the electric current passes through it? The same thing will happen here. When the electric current passes through the lamp will emit light. So the second part. of the electric, which is the electric lamp or the light bulb here, will emit light when the electric current passes through it. The third part, the wire. The third part is what? The wire. What is the function of the wire here? It's very important. Of course, it's very important. Why? Because it can connect between the battery and the lamp. Okay, now we put those parts and we connected all of them. What will happen in the electric circuit? First, the electric current comes from the positive pole to the negative pole and passes through the wire until it reaches to the lamp. And by using copper and lead wires inside the lamp, the electric current can pass from the base to the filament, and when it will reach to the filament, the lamp will emit light. So we know now what is the meaning of the electric circuit and what is the structure of it. It consists of 3 main parts: battery, lamp or light bulb, whatever, and the wire. Okay. Look at the following figure and tell me what is the difference between them. They are different or they are similar? Of course, they are different. Good. Why? Because in figure A, we can conclude that the electric circuit is closed. But here, in this figure, the electric circuit is opened. Here, all its parts are connected together. But here, all its parts aren't connected. The wire here is cut in. So, because here all these parts are connected together, the electric current can pass through the wire until it reaches to the lamp, so the lamp here can emit light. But in this figure, in figure B, its parts aren't connected together. So the electric wire can't pass through this wire because the wire here is cut in. So the lamp here will not emit light. It will be turned off. Okay, we can conclude what from these figures? We can conclude that the electric circuit must be closed. All its parts must be connected together to allow the electric current to reach to the lamp. And when it will reach to the lamp will emit light. Okay. If we want to connect the lamp in our houses, in our factories, in our streets, in our classrooms, we will connect the lamp in many ways, but we will talk about the two ways only. We have methods of connection. We have two ways if you want to connect the lamp. The first way is called series. Called what? Series. And the second way is called parallel connection. Parallel connection. Again, we have two methods of connection if we want to connect the lamp. Series connection and parallel connection. First, let's see what is the meaning of series connection. It's a way of connection. Okay, we know that the series, it's a way of connection in which or where the electric lamp or the light bulb are connected one after one in one route. Again, they are here, the lamp are connected one after one in one route, not in many routes. So if I ask you what is the meaning of series connection, it's a way of connection in which the light bulb are connected one after one in branching routes? No, in only one route. Here we have two figures. In figure A, in the electric circuit, we put only one lamp. It's connected in series connection. Here we put three lamps are connected only in series connection. But here in figure A, when we put only one lamp, the light intensity is very strong. And when we increase the number of lamps, the light intensity started to decrease until it will be very weak. Again, when we put only one lamp in the electric circuit, the light intensity starts to decrease. And by increasing the number of lamps, the light intensity started to decrease. So we can conclude that in a series connection, by increasing the number of lamps, the light intensity increases? No. Good. The light intensity decreases. Again, the first conclusion in a series connection tells us that by increasing the number of lamps, the light intensity decreases. Okay, do you think if I break one of those lamps, or if one of those lamps will burn out, do you think the other lamp will emit light? Don't forget that we are here in a series connection. We are here in a series connection. If one of those lamps is burned out or is broken, the other lamp will emit light? Good. They will not emit light. Why? Because we said in a series connection we have only one route for the electric current to pass through it. So if one of those lamps is broken or is burned out, the other lamp will not emit light. The electric current will not find the route to pass through it until it reaches to the lamp. So the other lamp will not emit light as you see in this lamp. So from those figures we conclude two things. The first conclusion tells us in a series connection, by increasing the number of lamps, the light intensity decreases. And if one of those lamps is broken or is burned out, the other lamp will not emit light. Why? What is the reason of it? Because here we have only one route for the electric current to pass through it. As you see in this picture, this lamp will not emit light, but those lamps or turn it on. Because this lamp is broken or is burned, the other lamp will not emit light. So until now we talked about what? What is the meaning of the electric circuit? What is the structure of it? What is the definition of the series connection? And what is the effect of increasing the number of lamps on light intensity? Okay. We said that we have two methods of connection. We talked about what? We talked about series connection. What about the parallel connection? It's also a way of connection. But here, the lamps are connected in branching routes. We have here one route, two routes. So we have two routes. So if you want to write the definition of a parallel connection, it's a way of connection in which or where the lamps are connected in branching routes. We have here many routes. Okay. In a parallel connection, in figure A, we connect two lamps. And in figure B, we connect three lamps. Do you think that in a parallel connection, by increasing the number of lamps, the light intensity will decrease also as we see it in a series? No, good. It will not decrease. So the first conclusion from those figures tells us in a parallel connection, by increasing the number of lamps, the light intensity remains as it is. It will not increase and it will not decrease. It will remain as it is. It will not change. Again, when we put here two lamps, the light intensity is very strong. When we put here three lamps, by increasing the number of lamps, the light intensity remains as it is. It will not change. Okay. In a parallel connection, if one of those lamps is burned or is broken down, the other lamp here will emit light. They will emit light or not? Do you think what? Yes, excellent. They will emit light. If one of those lamps is broken down or is burned out, the other lamp will emit light. Why? Because we see it in a parallel connection, we have branching routes. So if one of those lamps is broken down or is burned out, the electric current can find another route to pass through it. So from parallel connection, we conclude something. The first one tells us that by increasing the number of lamps, the light intensity remains as it is. It will not change. And the second conclusion tells us if one of those lamps is broken or is burned out, the other lamp will emit light because they have branching routes, many routes for the electric current to pass through it. Now we talked about what? We talked about the electric circuit, the structure of it, the methods of connection, which are series and parallel. Okay, what is the life application for methods of connection? We can use it in our life in what? We can use it in what? In lamps. All lamps in our houses, our factories, our streets, our classrooms, especially decorative lamps, do you think they will be connected in series or in parallel? Of course, they will be connected in parallel. Why? We have to connect the lamp in our houses or the decorative lamps, especially in commercial stores, will be connected in parallel. Why? What is the reason of it? To avoid if any one of them is broken or is burned, the other lamp will emit light. For example, if we are now sitting on a television in our house and one of those lamps is broken, do you find the other lamp will not emit light? No, they will still emit light. Why? Because the lamps in our house are connected in parallel. Okay. So, we can summarize our lesson today in these figures. We talked about what? We talked about the electric circuit, which consists of three main parts: battery, light bulb, and wires to connect between them. Then we talked about the method of connection: series and parallel. We said in a series it's a way of connection in which the lamps are connected one after one in one route. But in a parallel connection, it's a way of connection in which the light bulb are connected in branching routes. 1, 2, 3. We have many routes here, but here we have only one route. We said also that in a series connection, by increasing the number of lamps, the light intensity decreases. But in parallel connection, by increasing the number of light bulb or by increasing the number of lamp, the light intensity remains as it is. It will not change. We said also, in a series connection, if one of those lamps is burned out or is broken, the other lamp will not emit light, because here we have only one route for the electric current to pass through it. But in parallel connection, if one of those lamps is broken or is burned out, the other lamp will emit light, because here we have branching routes, many routes for the electric current to pass through it. Again, for the last time, today we talked about what? The electric circuit, the structure of it, the methods of connection, which are series and parallel. Thank you for your listening, and I wish you a good day. Goodbye.